Day 686 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3567, minimum absolute difference in sliding submatrix. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n integer matrix grid and an integer k. For every contiguous k by k submatrix of grid, compute the minimum absolute difference between any two distinct values within that submatrix. Return a 2D array ANDs of size m minus k plus 1 times n minus k plus 1, where ANDs of I and ANDs of j is the minimum absolute difference in the submatrix whose top left corner is I, j, and grid. Note, if all elements in submatrix have the same value, the answer will be 0. A submatrix x1, y1, x2, y2 is a matrix that is formed by choosing all cells matrix of xy, where x1 is less than or equal to x, and x is less than or equal to x2, and y1 is less than or equal to y, and y is less than or equal to y2. Boom, y'all. So I know that seems a little bit confusing. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have an input grid equals a 2D array of integers or grid. First row being 1, 8, second row being 3 and negative 2. K equals 2. So before we go any further, let me just copy and paste this over here so you can see what the grid actually looks like. Because remember, these arrays just represent a different row in the grid. So this would be the top row, this would be the bottom row, and in the end, the grid would look something like this, right? Boom. So this grid is all, since k equals 2, this grid is already 2 by 2, so we don't need to find any other submatrices inside of this grid, because as you can see, it's already 2 by 2, k equals 2. And remember, we're looking for 2 k by k submatrix, or in this case, 2 by 2 submatrix. Since this matrix is already 2 by 2, then we don't need to find any extra submatrices. It says the output is 2. Explanation says there's only one possible k by k submatrix. That's what we were just talking about. 1, 8, and 3, negative 2. Boom. It says the distinct values in the submatrix are 1, 8, 3, and negative 2. So let me copy and paste these as well so y'all can see the distinct values. So these are the distinct values, and we want to find the minimum absolute difference between these distinct values. It says the minimum absolute difference in the submatrix is 1 minus 3, which equals 2. Thus, answer is 2D array of integers 2. Boom. That's how we added this 2 in here. So the minimum absolute difference out of all these integers is 2, right? We want the absolute difference. The difference between 3 and negative 2 is 5. The difference between 8 and 3 is 5. The difference between negative 2 and 1 is 3, right? We want the minimum absolute difference. And the difference between 1 and 3 would be 2, which would be the minimum, right? It can be proven that there is no smaller absolute difference in this grid. So that's why we add this 2 to our output array. Boom, that's where that comes from. Now, just in case that didn't make sense, y'all, let's take a look at example 2. So in example 2, our input grid equals, in the 2D array of integers of just one row, 3 and negative 1. This time k equals 1. So boom. So this is our only row this time. So we come over, let me copy and paste this over here. This is our only row in the grid. K equals 1, so we need a 1 by 1 submatrix. It says both k by k submatrix has only one distinct element, thus the answer is 0, 0. So we can make two different submatrices, right? Because since it only need to be one. That could be a submatrix, and that could be a submatrix. It says right here, if all elements in the submatrix have the same value, the answer will be 0. So since there's only one element in this matrix, and one element in this matrix, that means every element in this matrix has the same value because there's only one element. Same with this matrix. Every element in this matrix has the same value because there's only one value. So we return 0 for the first matrix that we made with this 3, and then we return another 0 for the second matrix that we created with this 1. Boom. Now, just in case that didn't make sense to y'all, let's take a look at example 3. So in example 3, our input grid equals a 2D array of integers or a matrix. First row being 1, -2, and 3, and then the next row being 2, 3, and 5. This time k equals 2, so we're going to be looking for a 2x2 submatrix. So let me copy and paste this over here so we can find what our submatrices will be. Boom. Build this first matrix right here. Boom. So this is what our matrix looks like now. Oh, hold on, let me just clean it up so it looks good. Boom. So this is our first matrix. This is the top row. This is the bottom row. We want k equals 2, so we need to create 2x2 matrices, right? So there's only 2x2 matrices that we can create. We can create a 1, comma, well, let me put it in the brackets. We could put 1, comma, -2. That'd be the first row, and then second row would be 2, comma, 3. Hold on. 2, comma, 3. Boom. So as you can see, this right here is this submatrix, this 2x2 submatrix right here. Boom. See this 2x2 submatrix? Boom. That's this. Then we need to create this submatrix as well, right? There's another 2x2 submatrix that we can create, and that's this one right here. So let me just go ahead and do that. So that would be -2, comma, 3. And then it would be 3, comma, 5. Boom. Let me clean that up. Boom. So this is this submatrix right here. So let's go through the distinct elements in the first one. This first one has distinct elements of 1, -2, 2, and 3. So let's just write those down so we don't confuse ourselves. 1, -2, 2, 2, and 3. Boom. So we have one. Those are those distinct values. Then here the distinct values would be, it would be -2, comma. There's 2 3s. We just want the distinct values, so we can put 3 and then 5. Those are distinct values. Boom. So let's keep going. Let me just say distinct. Hold on, y'all. Distinct equals boom. Then we come down here. Distinct equals, sorry y'all, distinct equals boom. So these are our 2 distinct values. Now let's keep going, right? So this is our input, boom. This is our grid right here. The output is 1 and 2. So let's see how they got that 1 and 2. So explanation says there are 2 possible k by k submatrices. That's this right here and this right here. It says starting at 0, 0. So 1, -2, and 2, comma, 3. That's this submatrix right here. The distinct values in the matrix are 1, -2, 2, and 3. So we have the distinct values 1, -2, 2, and 3. It says the minimum absolute difference in the submatrix would be 1 minus 2, which equals 1. So let's see. The difference between 1 and -2 would be 3. The difference between 1 and 2 is 1. The difference between 1 and 3 would be 2. Boom. The difference between -2 and 2 would be 4. The difference between 2 and 3 would also be 1, right? It's still 1. So right now 1 is still the minimum. It's just different ways we can achieve 1. The difference between 2 and 3 is 1, and the difference between 1 and 2 is 1, right? So in this case, minimum absolute difference equals 1, right? So we add 1 to our output array. That's where this 1 comes from. Now we need to also find the minimum absolute difference for this submatrix, right? So the minimum absolute difference for this submatrix, we already know is 2, but let's go through it, right? So -2 and 3, that has a difference of 5. 3 and 5 has a difference of 2. -2 and 5 has a difference of 7. So the minimum absolute difference from this would be come from the 3 and the 5, which would be 2. So that's where this 2 comes from, right? So we could just come right here, minimum absolute difference equals 2. So all we're doing, we're taking this 1, adding, sorry y'all, we're taking this 1 and we're going to add it to our output array, and then we're going to take this 2 and add it to our output array as well. And then in the end, that's how we got this 1 and 2 for this output, y'all. So boom, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it now. The first thing we need to do is we need to get the number of rows. So we're going to say let m equal grid.count. Boom. Then we need the number of columns. So we're going to say let n equal grid square bracket 0. Sorry, y'all. Square bracket 0. Come outside of that, dot count. And once again, this is going to get the columns. Now, there's an edge case. If k is equal to 1, then every submatrix is a single element, so there are no pairs to compare, and the minimum difference will be 0. So we could just handle that by coming underneath this. We could say if k equals 1, we could open up the brackets and we could just return an array. Open up the parentheses, it's going to be repeating, repeating, colon 0, comma, count, colon, n. Or actually, sorry, y'all, we're returning a 2D array. So it's going to be an array repeating, colon, another array, because we're returning a 2D array, then that array is going to be repeating colon 0, comma, count, colon, n. Then we'll come outside this array in this parentheses and we'll say count, count, colon, m. Boom. Now we need to create our result matrix, and the dimensions are reduced because we are taking k by k submatrices. So we'll come underneath this, underneath this, and we'll do underneath the if, and we'll declare a variable called and set that equal to an array. And this is going to be the same thing. So we could just copy and paste this, but we're going to change some things. So, but it's going to be a 2D array again. So this time it's going to be, this is going to still be repeating 0, but the count is going to be n minus k plus 1, right? Like they give us up here, n minus k plus 1, and then this count is going to be m minus k, like right here, m minus k plus 1. Boom. Then we could come underneath that, and we need to iterate over all possible top left corners of the k by k submatrices. So we're going to come underneath this, and we're going to say for I and 0 dot not less than dot open up the parentheses m minus k. We'll come outside of that. Let's clean this up. Come outside of that. Open up the brackets. Then we're going to say for j and 0 dot open up the parentheses n minus k. Come outside of that. We're going to open up the brackets, and we need to create a temporary array to store all elements in the current k by k matrix. So we'll declare a variable called r colon square bracket int. Come outside of that, and we'll set it equal to a blank array just to start. Then we're going to collect all elements inside the k by k window. So we're going to say for x in I dot less than, open up the parentheses, I plus k. Come outside of those parentheses, open up the brackets, and we're going to say for y and j dot less than, open up the parentheses, j plus k. Come outside of those parentheses, open up the brackets. We're going to say r dot append, open up the parentheses, and we're going to say grid square bracket x. Come outside of that, square bracket y. Boom. Now we're not done yet, because now we need to sort the elements so that the closest values are adjacent. So we are going to come underneath this for loop right here, and we're going to say r dot sort, put the parentheses, boom. Then we're going to initialize minimum difference to a large value. So we'll declare a variable called min diff and set that equal to int.max. Boom. Now we're going to compare adjacent elements to find minimum absolute difference. So we're going to say for t in 1 dot dot less than r dot count, we'll open up the brackets. And we're going to skip duplicates since their difference is 0. We'll handle that case after the loop. So we'll say if r square bracket t, come outside of that, equals r square bracket t minus 1. We're going to come outside of that, open up the brackets, and we'll continue. Boom. Then we're going to update the minimum difference. So we'll come underneath this, and we're going to say min diff equals min, open up the parentheses, min diff, comma, r square bracket t, come outside of that square, sorry y'all, this should be square bracket t, come outside of the square bracket, we're going to say minus r square bracket t minus 1. Boom. Now, if all elements were the same or only duplicates, the min diff was never updated and we could set it to 0. So we could come underneath this for loop right here and we could say if min diff equals int dot max, we can open up the brackets and we'll say min diff equals 0. Boom. Then we're going to store the result for the submatrix by coming underneath this, and we'll say and square bracket I square bracket j, set that equal to min diff. Boom. Then we're going to return the matrix of the minimum difference. All we have to do is come right here, and we can say return and, y'all. Boom. That should be all she wrote. Let's give it a run. It's accepted. That's what I'm talking about, y'all. So let's submit it. Make sure it's still accepted. Boom. And look at that, y'all. 3 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see right there, y'all. So with that being said, make sure you get one more look at the code. This is the top. This right here is the bottom, or this is the middle of the code. And this right here is the bottom of the code, y'all. And with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.